Okay. So my name is Anton Epple. I'm a trainer and a consultant, and I run a little company called NetBeans. Apparently, according to the program, actually, my company's name is DukeScript, but I'm on the NetBeans Dream Team, and that somehow got mixed up. So I'm not the owner of NetBeans. If you wanted to meet him, you have to go to Larry Ellison. I'm on Twitter, Monaco Toni, and I run this website, DukeScript.com, where we share news about our technology. So DukeScript is a solution to a problem that appeared to me and other fellow Java developers, Java front-end developers, when we found out that Swing, or later then JavaFX, didn't get us on the interesting devices. It was really around that time when the iPhone came up and there was no Java running on the iPhone. And then Android came along, and well, there was some kind of Java on Android, even if there are discussions about it. It's a fork of Java in a way. And even though that is great, we cannot really write cross-platform applications as we could with Swing. And that was basically the motivation. So we said we want to get Java running on all these devices again. And so we thought, how can we do that? We do not want to implement a whole UI toolkit as the JavaFX guys did, because it really is hard work to port this to new platforms. So we thought we were looking for a simpler way of getting the same results, even better results actually. So what we created is, or what our main aim was, to create a Java single source cross-platform framework. Single source, one source that you can deploy, and you can deploy to all the platforms, and well, cross-platform, and Java because we like the language. And Stephen Chin, who is running the Java 1 content chair, and is a long-time JavaFX guru, said DukeScript is the lightweight JavaFX he always dreamed of. That was very nice of him. So, but before we start, I would like to show you a little demo that you'll see a couple of times, and I hope the screen resolution will allow me to run it. And it's a little game. So I'll start. This is NetBeans. Who of you is using NetBeans? Yay! We're using, for DukeScript development, we're using mainly NetBeans. You can also use Eclipse for it, but we're mainly using NetBeans. So this is a little game. You probably know it from, you have these tiles and you have to bring them into a certain order, and you can shuffle them, or you can try to bring them into a certain order. And that is a simple graphical game. And we wanted to have this as a demo application to run it on the different platforms. So how does this work? What we need in order to make DukeScript run on a platform is we need a Java virtual machine, and we need an HTML renderer component. And we somehow instrument this HTML renderer component from Java and glue them together. And by gluing them together, what we do is basically we bind the UI to models, to view models that are written and defined in Java. So what happens is the JVM executes the business logic that is written with our DukeScript APIs, Java APIs. So developers just have to code Java. And DukeScript and its Java APIs control this renderer component, which renders the result. So the example that you just saw was using JavaFX. So we have the hotspot virtual machine, we have our DukeScript APIs, and we have the JavaFX scene web view component. And this web view component is capable of rendering HTML5. So that's really pretty easy to do because it also has really nice integration with JavaScript. So we can call under the hood JavaScript APIs and execute JavaScript code, manipulate the DOM, do stuff like that. And that's really, really easy to do. On other platforms, it's slightly more complicated. Like on Android, for example, we have Dalvik, which is a nice virtual machine, or Art now. And we have DukeScript APIs, but we have the Android WebKit WebView, which is typically, if you invoke JavaScript in there, it's invoked asynchronously. So we have to do some tricks to make it work, to really make it synchronize. But just as with the demo I showed you on the desktop, I can show you that it works here as well. I've got this little game here, so I hope you can see it. It's just the same game, and I'm even capable of solving it. On iOS, we are using a virtual machine called RoboVM, or it's not really a virtual machine. What it does is, under the hood, it uses LLVM to compile Java code to native code. And it has APIs for all the controls that we have on iOS. And one of these controls is the UI WebView, and that's what we are using here to make the applications run. So I'll show the same demo. Okay, so I should also be able to solve this one. Okay, so it's the same source code that runs on all these platforms, and it's also, in this case, the same UI definition that runs on these platforms. But we do not only run on iOS and Android, where we somehow have a virtual machine or something like that available. We also run in the browser as basically a replacement for applets, but a better version of applets actually. And this is done via two virtual machines that we support right now, back to browser and TVM. These are Java virtual machines that can pre-compile code to JavaScript, Java code to JavaScript, or run it in interpreted mode, real bytecode. And we use Chrome or another browser as the executing environment. So in this case, the HTML5 renderer also hosts and runs the Java virtual machine. So I can show you the same game, hopefully in the browser. Okay, so it's here. And you can see it runs and looks just the same as on the other platforms.
But it's basically everything is happening on the client side, on the browser, right?
Everything is happening on the client side. Everything is happening in the browser. DukeScript is pure client-side technology. We have something for the server side as well, because what we can do is we can reuse code. We can reuse the model code, the same model code on a Java EE server as we use on the client, and the same APIs. That's the benefit of using DukeScript in combination with the server. But in general, our main focus is to provide client-side UI toolkit for you. So the applications, because I heard this question today, you do not need to jailbreak your phone in order to run these applications. These applications run, you can deploy them to the App Store and you can sell them there. We have this example application, Fair Minesweeper, that is on Google Play and on iTunes. And I can show it to you. It also runs in the browser. It's Fair Minesweeper. I don't know, who of you has played Minesweeper before? Okay, that's the best turnout today from my questions today. Okay. Well, the thing in the beginning of Minesweeper, you typically click around in order to free as many fields as possible. And the fair Minesweeper doesn't allow that, because you should start thinking right now, because here you can, here must be a bomb. Okay? So if I click somewhere here randomly, it will just punish me and put a bomb there. So that's fair Minesweeper. Nice game, you can download it. It gives you maybe two hours of fun, and but it's just a demo application. Okay. So what we have for the developers is we want to make it easy for them to create the applications, and we wanted to make it really smooth to develop the applications, to modify the applications, and to test them. So because I'm running the company NetBeans, the plugin, the best supported IDE is NetBeans, but you can also use Eclipse for the development. I haven't tried with IntelliJ IDEA yet, because I wanted to do something with it, but the Maven support was really very counterintuitive, so I didn't get the projects to run. But basically, our projects are Maven based. We provide archetypes for Maven, so you can get started with any IDE basically. But NetBeans is really very well supported. So we have this plugin, and with this plugin we can create an application, and we can compile it, we can run it, but we can also visually debug it, and I'll show you that. So I'll create a new application. There's a category DukeScript if you install the plugin. And I'll give it just a artifact ID. Carry on. And the base package. And then I can choose whether I want to run this in a browser, on Android devices, on iOS devices, and so on. And the interesting fact about this, this wizard here is that it's also written in DukeScript. So you can also create, you can embed DukeScript in Swing applications, you can embed DukeScript in JavaFX applications, and it's quite non-intrusive. So in case somebody tries to create an IDE based on that is supposed to run in the browser sometimes, this API would perfectly fit in here. It would run on the browser as well. And we provide two basic archetypes that you can play with. The first one is a CRUD archetype that has a server component and a client component to illustrate that we can share code. And the second one is a pure client archetype, and you can decide whether you want a little bit of demo code or if you want to go with an empty sample. We'll add a little bit of demo code. Okay. So you see, for each of the platforms, we get a project created. This is the Android one, this is the iOS one, this is the web version, and this is the shared client code that will run in JavaFX. And this is basically the container for these modules that builds them. So in the meantime, the projects have been built, and I should be able to run them. So let me do it like this. And this is a very simple demo. We have, you can see the, I type something into the inbox, and it synchronizes with these little boxes down here, and I can do some rotation, stuff like that. Very simple application that shows you, it's basically a tutorial in its own to show you how to write tests and stuff like that. What I want to show you with this is how easy it is to develop with DukeScript. So screen real estate. So you have to invest in a second screen if you want, if you really want to do this. It really makes life much easier. But what you can do here is you can inspect, live inspect the application. See here, I have this span here, and it gets highlighted in the running application. And I also get the CSS styles and everything. It's just like JavaScript developers know from Firebug or these Chrome developer tools, but really integrated into your IDE. So you do not have to leave your IDE in order to do something with the sample. And you can also manipulate the code here. For example, we have these spans here. And this one has a margin on top of 0. And I change the margin, and the application live updates. So I can manipulate the view, just save and code and edit the view, edit CSS and so on, and that's quite nice. I can also debug the application, obviously. It's a Java application. By the way, I can not only debug it on the desktop, but I can also debug it on the device. So if I run the application on my iPad, I can debug it and set breakpoints, and it will stop. Okay. So I'll start the application again in debug mode, and I set a breakpoint here, and in the background something is happening. I've stopped on this breakpoint, and I can now inspect the object. What is nice about model objects in DukeScript is that they have a toString method that creates a JSON message, so you can immediately see how the fields, how the properties are filled, and you can see the values. Okay? So, sorry. I'm confused because of the layout, because of the small resolution. Okay. So we have this debugger, and since recently we also have hot swapping, and I have to change something in the code there before it runs. Because there's a bug in the spring-loaded framework that we use for this. I better do a clean and build in order to make sure that it has the most recent version with the bug fix. And I run the application again. And now I want to change the code. So first I change something here. Type Prague again. And now I go into the data model. And in this data model there are some methods. For example, this here is responsible for splitting the string in the input field and creating these little words. Okay. And in here I'm going to, before I split the message, put everything to uppercase. And then I split the message. So just hit save, go back to the application, and the application now has changed as well. So I really did hot swap the class file here, and that is really nice because in Java you can do that because the data is separated from the class file, so we even keep the state. So JavaScript developers have something similar. They can also write JavaScript code and can hit save, but they need to reload. That means they cannot keep the state of the application. And we can keep the state of the running application because we use Java. So that is really, really nice. You can develop your application while it's running. It's much nicer, you have to trust me, if you have a second screen. It makes life so much easier. But you can imagine that this is really nice for client-side development. We also have our own version of JS. Any JavaScript developers here? Okay, you know JS Fiddle. So we've got our own small version of JS Fiddle where you can run the application in the browser. What is really cool about this, that it actually runs JavaC in the browser. So you can live code here with code completion and so on, and you can hit compile, and it will compile the application in the browser, and it will run it in the browser. But we don't really use it just for demo purposes typically, and just to show that we can. What we are using in order to program the application, our APIs are following the model view model pattern, and that is basically created from a view. The view is, in our case, in our example, HTML, and the view knows something about the view model, but the view model doesn't know anything about the view. We'll come to why this is really helpful in a second. And the view model knows the model. The model is basically the rest of the application and can do something, can get data from the server also. But the view model is basically what our Java APIs are good for. And in order to define the view model, we didn't want to go the Java path. The typical Java path is that you create a property, and you have a getter, you have a setter, you have property change support, stuff like that. And that is really annoying. There's really a lot of code for nothing. So what we did instead was we created a couple of annotations, the model annotation and the property annotation. And this is basically, it looks already like a JSON message basically. You define that you want a class named task. It should have a property named title of type string and a property of name complete of type boolean. And this is what the annotation processor will generate for you. And since Java 6, the annotation processors can do that in the background, and that works in Eclipse as well as in NetBeans. It's basically IDE independent. They will create the class for you, compile the class for you, and you will have it available immediately. And here's another more complex model that also uses the class we defined first. So this is basically the view model of a to-do list application. And then the generated class can be used right away. And you can say like new task list view model, get tasks. This getter has been generated automatically for you. So here, that's what you get, the task. It's of type array. So we'll get back a list and we can add a new task there. So it's really very, very simple. And you can also have functions. That's what the view can call. So because if you click a button in the view, something has to happen with the view model. And for this, we define functions. And for example, we have this add task function, very simple, creates a new task, and adds it to the list of existing tasks. ToString of our model creates a JSON string, so it's also very easy to deserialize the message and send it to a server and get it back from the server. So if you already have a RESTful server, it's very easy to integrate it with this. We also have some very, very simple ways of creating REST endpoints in your application. So you just have to call a method, basically, and it will automatically retrieve data from the REST service, convert them into objects, and you will get objects, basically. It's really very comfortable. And the last thing that you need to do if you use the generated class is you need to apply the bindings. Okay. So on the view side, we are purely declarative. So you have simple HTML, And what we do is we're using knockout and to declaratively bind the properties of our HTML to our data model in Java. So here, for example, we say we bind a text to the full name property of the current scope object. And here we can do for each, so we can iterate over a list of addresses in this point, and inside of this for each block the scope is changed, and we can bind to properties of the objects in there. And this is really nice for doing test-driven development. So this pattern, because the view knows the view model, but the view model doesn't know the view. We can code the whole logic without having coded the view. And we do not have any references to widgets or something like that inside of our view model classes. So for application, a different application, I can show you that. That's the wrong one. I have an application, you can find this on GitHub, where I created a lot of tests for the view model, and it's the view model that I just defined in the slides. So for this view model, I can now code a test. Just using JUnit, or testng in this case. Test add task. I want to task how to add a task. So I'll create a new task list view model. And I will make sure that the list is empty. So I'll get the tasks, check the size, and compare with 0. And then I'll manipulate the text. I'll say set input, which manipulates, which basically simulates typing by milk, and I'll call add task, which basically simulates the button click. And then I can do again my assert equals, and make sure that now I have a size of 1. And let's run this test. And the test has succeeded. I can also prove that it doesn't succeed if I run it. Okay. So without the need to start the UI. You have a question?
Yeah. Where did the task list view model class come from? Is that something you wrote, or?
That is what we defined here in the. So here I use these add model and add property annotations to create the task list view model. It has been created in the background for me through an annotation processor.
Okay. So that's what will happen with all the view models.
Exactly. You define them like this, and if you have functions like the add task function that we called, you define them like this. So you have a static method here that the actual class can call into. So that is really cool, because when I was doing UI development, we had the problem that that typically you could not really test the application, right? It's really very hard to test the application. You have to have robot class or some strange frameworks that launch the application, simulate button clicks and stuff like that. But with a pattern like this, it's really easy. So you can test the full functionality of your view and just in the end write the view and attach it. And this also enables a really nice designer versus developer workflow. So you can give all the work, the design work, to an external designer, and he can do, he can create the HTML and the CSS and everything for you. So you code your Java application, and you give a design to a ready-made design to an HTML developer, and he will be able to create the view for you. And I tested this, I tested this myself by buying a design on one of these graphic river pages online and gave it to a service that is XHTML to or PSD to HTML on the web. I didn't have any communication but a web form. I just submitted the design and they gave back the design to me, and I applied it to the application and it worked perfectly. So I can also show you this application. It's running on here. I was really very happy with that because a lot of frameworks claim that they can do that they have a designer developer workflow. But typically what they have is they have a declarative design format that they can give to their designer, and he will have to learn something new. And he will have shitty tools and will be frustrated, and nothing will come out of this. And with this approach, you can just use HTML, and there are tons of HTML developers out there, designers who can really work with that. So, and here we have the application. And I can add something here and do stuff with it, and it works brilliantly. And that is really, really nice because it really streamlines your development process. We have a lot of additional APIs. We wished we had even more, and fortunately the community is starting to pick up the different goals. For example, we have a Canvas API for doing direct immediate mode rendering, so you can create games or something like that. We have a camera API, so you can take pictures with your device and store them on the device or send them to the server. We have geolocation API, so you can track GPS signals. We have a map component based on Leaflet. And we have an additional partner here in Czech Republic, and he creates this controls.js, which is basically a rapid application development tool that makes it really easy. And this is the last demo I'll do. It's also very neatly integrated into NetBeans. And so with this tool, what you can do is you can drag and drop controls here and containers and do data binding. All of that just via clicking some buttons. So for example, if I select a component here, I can say data bind to to-dos, and this will bind to a DukeScript model. So you do not even have to create the HTML. You can also do for simple applications like this drag and drop style application development, and it will create a cross-platform application really via drag and drop. And works just the same as the other parts. Okay. I need to switch back here. We're currently developing, going onto new platforms like Raspberry Pi, embedded systems. It already runs on the Raspberry Pi, but we are also targeting for a customer different platforms. And we are also targeting Android Wear, because Android Wear does not really work yet because it doesn't have a web component, web renderer component. So I cannot run DukeScript applications on my watch right now, which is horrible. What we have to do in order to support that is also to support native controls. Unfortunately, our APIs also allow that. Okay, I think
we have a few minutes for questions.
We have a few minutes for questions. Okay.
Okay. First of all, about these native components, I won't even. Okay. I won't even start the subject because it's like few hours or days talk, right? About native versus HTML. But actually, you know, you have a lot of stuff already like this, that you're writing HTML front and then writing it on iOS, on Android and so on. So my question is, what's more? Because I understand the whole point of this is that Java is compiled and run on the client side, and actually the communication could be just done as a REST service, like anything else. So basically, this is the whole thing, that the browser is running compiled Java.
So the basic idea is to be able to create cross-platform applications in Java. Because
yeah, but still we are using HTML engine, right?
Yes, we are using an HTML engine. That is what we are currently doing. We can also use native components. That is what is currently under development for Android, to make it really more native. And then it's basically just a real native application. That is, well, it's running in a virtual machine in Dalvik, and it's rendering native components, so it's a native application.
Okay, so I have another question.
Yeah.
A follow up a little bit. What is because you only just mentioned that there is a Canvas API.
Yeah.
So what is the support for different? If I don't want to go with your model view and model thing, what is different support for other frameworks, front-end frameworks?
So if you don't want to use model view model, you can, for example, use the Canvas API, and because that is not that is totally independent of it. So it really depends on what kind of applications you want to create. If you want to create a form-based application, then this model view model is perfect.
Yeah.
If you want to create a game, then forget it. It's maybe nice for the screens or something like that, but not for the game itself.
But how would you then separate this?
You can combine them and you can separate them. You can just create an application and just use Canvas and don't use the model view model APIs at all. That is possible. The basic demo. We also have an archetype for Canvas, and if you use that, there is no knockout. It's just like a drawing program or something like that. Okay.
So the demo projects are over there, and also the one for the Canvas, right? The demo for the Canvas is somewhere on the web. I would find it.
Yes. You'll find it. You'll find it here.
Yeah, that's great.
Yes. Okay.
So I would extend the previous question in a much broader direction. What is generally your story for interoperability with existing libraries on set platforms? So if I want to reuse some JavaScript library when I compile to the JavaScript platform, how would I do that? How easy it is?
It's actually fairly simple. We were inspired basically by GUID, the Google Web Toolkit, and we have an annotation, JavaScript body, that makes it really easy to create a type-safe wrapper around existing JavaScript API. So, for example, the Canvas API is doing exactly that. If you want to see how to do it, just download the Canvas API and see how it's done in there. You basically write a JavaScript call, also with an annotation, and define which parameters go in there. and add it to a talking about code. So like, for example, exactly like here. So this is basically even showing a more complex interaction. So we're calling, in the body, this is JavaScript code. And what we pass in here is a string message. And we call confirm method in JavaScript, which will show a dialog. And then, as a result, we will invoke a Java function. And there's this also copied from basically from Google Web Toolkit, this specific syntax for calling into Java. So you can interact in both directions.
Unfortunately, that's all the time we have.
Okay. So just ask me afterwards. Thank you. Really around that time when the iPhone came up and there was no Java running on the iPhone. And then Android came along and, well, there was some kind of Java on Android, even if there are discussions about it. It's a fork of Java in a way. And even though that is great, we cannot really write cross-platform applications as we could with Swing. And that was basically the motivation. So we said we want to get Java running on all these devices again. And so we thought, how can we do that? We do not want to implement a whole UI toolkit as the JavaFX guys did, because it really is hard work to port this to new platforms. So we thought we were looking for a simpler way of getting the same results, even better results actually. We're using for DukeScript development, we're using mainly NetBeans. You can also use Eclipse for it, but we're mainly using NetBeans. So this is a little game. You probably know it from you have these tiles and you have to bring them into a certain order, and you can shuffle them or you can try to bring them into a certain order, and that is a simple graphical game, and we wanted to have this as a demo application to run it on the different platforms. So how does this work? What we need in order to make DukeScript run on a platform is we need a Java virtual machine, and we need an HTML renderer component. And we somehow instrument this HTML renderer component from Java and glue them together. And by gluing them together, Okay, so my name is Anton Epple. I'm a trainer and a consultant, and I run a little company called NetBeans, apparently, according to the program. Actually, my company's name is DukeOff, but I'm on the NetBeans Dream Team, and that somehow got mixed up. So I'm not the owner of NetBeans. If you wanted to meet him, you have to go to Larry Ellison. I'm on Twitter, Monaco Toni, and I run this website, DukeScript.com, where we share news about our technology. So DukeScript is a solution to a problem that appeared to me and other fellow Java developers, Java front-end developers, when we found out that Swing, or later then JavaFX, didn't get us on the interesting devices. What we do is basically we bind the UI to models, to view models that are written and defined in Java. So what happens is the JVM executes the business logic that is written with our DukeScript APIs, Java APIs. So developers just have to code Java. And DukeScript and its Java APIs control this render component which renders the result. So the example that you just saw was using JavaFX. So we have the hotspot virtual machine, we have our DukeScript APIs, and we have the JavaFX scene web view component. And this web view component is capable of rendering HTML5. So that's really pretty easy to do because it also has really nice integration with JavaScript. So we can call. So what we created is, or what our main aim was, to create Java single source cross-platform framework. Single source, one source that you can deploy, and you can deploy to all the platforms, and well, cross-platform. And Java because we like the language. And Stephen Chin, who is running the Java 1 content chair, and is a long time JavaFX guru, said DukeScript is the lightweight JavaFX he always dreamed of. That was very nice of him. So, but before we start, I would like to show you a little demo that you'll see a couple of times, and I hope the screen resolution will allow me to run it. And it's a little game. So I'll start. This is NetBeans. Who of you is using NetBeans? Yay!